In this video, we're again going to be discussing end behavior of polynomials. So really the two things you need to do when you're finding the end behavior, you need to determine the degree of the polynomial using the exponents. And then you need to look at the leading term and then do some test points to determine if your graph is going to end up positive or negative in each direction. So we need to be a little careful about how we're describing this. Okay, so the first step, we're going to work through an example here. The first step is to find the degree of the polynomial. Now remember, the degree comes from just the exponents. It does not matter what your coefficients are here. So in this example, my degree is 5 coming from the highest exponent. That's going to make it an odd function. Okay, so right off the bat, I know it's going to have what I refer to as split end behavior, meaning that it's either going to look like this or it's going to look like this. That is not enough information, right, to actually use words to describe the end behavior. So what we're going to do is we're going to look at our leading term, which is this negative 2 times x to the fifth. We're going to do some test points. We're going to choose one positive value and one negative value. We're going to plug it in just to that leading term, and it's going to show us which direction our graph is going to go, both in the positive direction for x and the negative direction. Because remember, we have to describe the right and left movement and the right movement as the graph is growing or decreasing, and the left movement. So I'm going to start out by plugging in positive 5. So again, I'm plugging in just to my leading term because the leading term holds the most magnitude. So whatever the leading term does, the rest of the polynomial is going to follow that example. So if I do negative 2 times positive 5 to the fifth power, it'll be negative 2 times, let's see, 5 to the fifth is going to be 3,125. And then if I multiply that by negative 2, I'm going to end up with negative 6,250. So obviously it's getting more and more negative. So what that tells me is that as I plug in larger and larger positive x values, my graph is going to become more and more negative. So my first sentence is going to say, as x gets larger and larger in the positive direction, meaning as I'm going to the right, f of x, my function, is getting more and more negative. Excuse me. Now, because this is an odd function, right, we know that since it's going down on this side, we know it's going to go up on the other side. But for the sake of this video, I'm going to go ahead and demonstrate why that's true. So just like I plugged in a positive x value, I'm going to plug in a negative x value to show that that's what's going to happen. So I'm going to do, again, my leading term, so negative 2 times negative 5 to the fifth power. Now with that exponent, you have to do this portion first. So that would be negative 5 times negative 5 times negative 5 times negative 5 times negative 5, which would give me negative 3,125. And now we know if I multiply a negative times a negative, I'd end up with that positive value. So this is telling me as I'm plugging in larger and larger negative values for x, I'm going to end up getting larger and larger positive values for my function. So as x, so I'm using basically the same sentence, but I'm switching out, right, these positive and negative directions. And that's just what happens in this particular case, right? So you always want to look for your degree, and then you always want to do that test point. Okay, So that's just one example, but you're going to follow those same steps every time. You're going to find the degree, and then you're going to do using your leading term, you're going to do test points. So we're going to do the same thing now. We're going to look at an even function. You can see my leading term is very similar, right? The thing about this is that since my degree here is 2, right? That's my highest exponent. It could be 2, it could be 4, it could be 6. As long as it's an even number, it's going to do one of two things. It's either going to have both directions going up, or it's going to have both directions going down. An even degree will always do that. It does not matter. Like, it could possibly do something like this in the middle, or it could, wiggle a whole bunch of times. But either way, both ends are going to face that same direction because it's an even degree. So again, I'm going to do some test points, and I'm going to do 5 again. That's an easy one. So -2 times 5 squared. So I'm going to do 5 squared first, right? Do those exponents first. That's going to be 25. And then if I multiply 25 times -2, that's going to be -50. So that's telling me that as my x values are getting larger and larger in the positive direction, my function values are getting larger and larger in the negative direction. Now, because it's an even degree, I know that both ends are going to do the same thing. So I can write out 2 sentences to describe that. I could also do a second test point, right? So -5, let's plug that in. When I square -5, I'm also going to get +25. So I'm still going to get -50. You can see here that it's going in the negative direction both ways. So I can say as x gets larger and larger in both the positive and negative directions, g of x, my name of the function, gets larger and larger in the negative direction. So I combined the 2 sentences into one here. You could write 2 separate sentences if you wanted to.